Have you ever wondered why data has become the new gold in our current age? Data, in its many forms, has become a primary asset, a veritable treasure chest of information for businesses and individuals alike. From predicting market trends to understanding user behavior, data is the key that unlocks many doors. In this digital age, every click, every swipe, every online interaction generates data. This explosion of digital data has created a pressing demand for efficient, secure, and massive data storage. We are not just talking about gigabytes or terabytes here, but petabytes, exabytes, and beyond. Data is not just about storage. It's about the power to predict, to influence, and to shape the world. It is the brush with which we paint the portrait of tomorrow, the compass guiding us through the labyrinth of the digital world. As data continues to grow in significance, the methods we use to store and manage this data must evolve. Let's rewind a bit and examine the traditional methods we've used to store data. Over the years, we've relied on hard drives, magnetic tapes, and optical discs to hold our valuable information. Each of these has its own strengths. Hard drives are versatile and can store large amounts of data. Magnetic tapes, although a bit antiquated, offer a cost-effective solution for backing up vast quantities of information. Optical discs, on the other hand, provide a durable and portable option. However, these methods also have their weaknesses. The physical size of hard drives and magnetic tapes can be a limiting factor, especially when space is at a premium. Optical discs, while compact, can be easily damaged and have a limited lifespan. Additionally, none of these methods are particularly well suited for handling the massive volumes of data we generate today. While these methods have served us well, they are not without their limitations, especially when it comes to handling the data deluge we are experiencing today. What if we told you there's a storage method that can fit all the world's data in a volume of a few sugar cubes? Yes, we're talking about DNA data storage, a fascinating intersection of biology and technology. Let's dive into the science. DNA, or deoxyribonucleic acid, carries genetic instructions in all living organisms. But scientists have now devised ways to use it as a storage medium. Here's how it works. DNA is composed of 4 bases: adenine, thymine, guanine, and cytosine. These bases can represent binary data, zeros and ones, making DNA a suitable candidate for storing digital information. But why DNA? Well, it's incredibly dense. A single gram of DNA can store about a zettabyte of data. It's also long-lasting and energy efficient. Unlike hard drives that break down over time, DNA can preserve information for thousands of years. DNA data storage could potentially revolutionize how we preserve and access our digital heritage. So, how does DNA data storage stack up against traditional methods? Well, in terms of storage density, DNA data storage is a behemoth. It's been estimated that a single gram of DNA can store about 215 million gigabytes of data. That's the equivalent of half the world's data in a device no larger than a sugar cube. Traditional methods, even the most advanced solid-state drives, don't even come close. As for lifespan, DNA doesn't degrade over time like magnetic tape or hard drives. It can last thousands of years if stored correctly. However, DNA data storage isn't without its challenges. The technology is currently expensive, and the process of writing and reading data is slow. Yet these are hurdles that come with any groundbreaking technology. With time and research, these issues will be addressed. After all, the idea of storing data in the cloud seemed far-fetched once, didn't it? Despite its challenges, the potential of DNA data storage is undeniable. Imagine a future where our data is stored in DNA, safe and sound for thousands of years. The implications of DNA data storage are vast and far-reaching. As we stand on the precipice of this technological revolution, ongoing research is uncovering new ways to refine and optimize this process. Consider the healthcare sector, where DNA data storage could revolutionize patient records, ensuring they're preserved for generations. Or the entertainment industry, where vast libraries of music and films could be stored in a space no larger than a sugar cube. Even in space exploration, DNA data storage could offer a robust solution to the challenge of storing the vast amount of data collected during long missions. As we continue to innovate, we're unlocking the potential of DNA as a storage medium. Data is no longer just information, it's becoming part of the very fabric of life. As we continue to push the boundaries of data storage, one thing is clear: the future of data is in our DNA.